Alright guys, so this is the video to start section 9.4 and we're going to merge 9.4 and 9.5 together. So this is where like trig really kind of sets itself apart from everything else. So most of what you'll learn this lesson is probably something totally new to you and you're going to kind of feel uncomfortable at first with it, but that's okay. We'll get through it. We'll do lots of practice. I think I told you we're spending about a week longer on this chapter than I normally do, so we'll give you time to get more comfortable with doing it. Just make sure you ask questions and don't let something kind of sit there and wait and hope you figure it out later. Okay, don't be shy to ask. All right, so here we have, I don't know, 10-ish triangles, and every triangle has 3 sides. Okay, so when we do trig, we're concerned with 3 sides. So you can see that there's this symbol next to one of the angles. Okay, and the angle it's next to, notice, is not the right angle. Okay, and so what I want you to do now is I want you to label all 3 sides. We have 3 sides. We have the hypotenuse, which we all should know what the hypotenuse is. The hypotenuse is always opposite of the right angle. We have the O for opposite and A for adjacent. Okay, so if my angle right here, here's my theta, and we'll talk about what this means here in a little bit. In this triangle, I always label my hypotenuse first, right? Hypotenuse is always opposite of the right angle. Okay, so that's my hypotenuse. The next side is the opposite side. So I want the side that's opposite of this angle here, of angle theta. So this side is opposite. And then the one left over is my A, which is adjacent to this angle that's not the hypotenuse. Okay, so I'm going to do that again. I always label my hypotenuse first. The hypotenuse is always opposite of the right angle. I'm going to label the opposite side, so of this angle, the opposite side is over here, and that leaves me with the adjacent. Okay, I'm going to do one more with you. So opposite of the right angle is always my hypotenuse. Opposite of my theta is my O. The one left over is my A adjacent. Okay, so I want you to go ahead and do 1, 2, 3, 4, 5. These last 5 on your own just to make sure you get the hang of it, and then we'll go over it. All right, so go ahead and take a look, and this is what you should have gotten for the rest. All right, now before we get into it, I want to go over a skill that you've learned in the past, and just to kind of refresh ourselves to make sure we know what we're doing when we see something like this. So when we're solving for a fraction, anytime we have a fraction, it kind of complicates things. So rule of thumb is anytime you have a fraction, you want to multiply by the denominator, but remember, if you do it on one side, you have to do it on both. And the reason we want to do that is because, think of this as 5 over 1. These would cancel each other out. So you're just left with x equals 13 times 5. And 13 times 5 is 65. So x then has to be 65. Okay? It shouldn't be complicated. We're going to be using this, and I want you to be comfortable with it. Okay, so on number 2, same thing. 78 over x equals 9. So we want to multiply by the denominator. If we do it on one side, we have to do it by the other. So those go away. I'm left with 78 equals 9x. Divide both sides by 9. That gives us 78 over 9 equals x, which reduces to 26 over 3. Okay, now go ahead and do 2 and 3 on your own, and then we'll go over it. All right, so on number 3, we're going to multiply both sides by 4, and then we're done. You just get x equals 116. Okay, number 4 requires a couple extra steps, so we're going to multiply each side by x, and then we get 115 equals 30x. Divide both sides by 30. you get 115 over 30, which then reduces to 23 over 6. All right, so we have quite a bit of vocab that we need to go over. The first one is the angle of elevation. Okay, the angle of elevation is an angle that an increased line of sight makes with a horizontal line. Okay, now that seems like a lot, but when I draw the picture, hopefully it'll make more sense. So you will always start with a horizontal line, okay? And if we're going to increase something, that means we're going up. So if we go up, this would be the angle of elevation. Okay, now angle of depression is kind of same but different. It's the angle that a decreased line of sight makes with a horizontal line. Okay, so once again, we always start with the horizontal line. Okay, and decrease means we go down. So if we go from here and we go down, this would be the angle of depression. Okay, now theta, that's what you've seen when we did this. It's this funky looking symbol right here. So theta looks like this. And it's a Greek letter that generally represents an unknown angle measure. So an unknown angle. Okay, so think of it as like an x in algebra. Okay, when you first started this, you've seen an x in algebra and it scared you to death. But now x is just something that we put in place of something we don't know. That's kind of what a theta is, okay? Except the only difference is usually you see it at an angle. It's an unknown angle. All right, so in trig, we have 3 ratios, okay? We have the tangent ratio, the sine ratio, and the cosine ratio. Those are our main ones. And so we're going to be doing a lot with sine, cosine, and tangent. And notice it's a ratio. And when I say ratio, your head, you should be thinking a fraction, okay? So the tangent ratio is just the trigonometric ratio for acute angles that involve the lengths of the legs of a right triangle, okay? So these only work for right triangles. And the tangent ratio is always the opposite side divided by the adjacent side. Okay, so it's opposite over adjacent. Okay, the sine ratio is also a trigonometric ratio for acute angles that involve the lengths of a hypotenuse of a right triangle. And my sine ratio is always the opposite side over the hypotenuse. Okay, so my sine ratio is always opposite over hypotenuse. Okay, last but not least, my cosine ratio. It's the third of my trigonometric ratios. For acute angles, and once again, we're only talking about right triangles, and my cosine ratio is always my adjacent side over my hypotenuse. Okay, so it'd be my adjacent over hypotenuse. All right, so one more page of vocab, and then we're going to be done with vocab at least. So the opposite leg of a triangle, now this goes back to what we did up here. Okay, so we've already done the hard part. It is the opposite of the angle of concern, or the theta. Usually this is my theta. Not always, but usually it is. Okay, the adjacent leg of the triangle is adjacent to or next to, and I'm going to put in parentheses, but not my hypotenuse. Of the angle of concern. All right, guys, my hypotenuse has a typo in here. So the hypotenuse is the side opposite of, not or, of the right angle in a right triangle. And we know that the hypotenuse is always the longest of the three sides. And just in general, trigonometric ratio, it's just the ratio of the lengths of two sides in a right triangle. All right, now the most important word in all of trigonometry is right here. It's actually an acronym. We call this SOHCAHTOA. So SOHCAHTOA. So I encourage you, and I know it might sound silly, but I encourage you to say SOHCAHTOA, 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 15, 20, 50 times, I don't care. But you will have to know this, okay? And the best way to get to know it is just to say it over and over and over. All right, so what this acronym stands for, if I take the first of all these, my S, my C, and my T, these stand for my sine, my cosine, and my tangent. Okay, now we have abbreviations for each of these. So my sine is actually written as sin, but don't call it sin, it drives me nuts. My cosine is written as COS, and my tangent is shortened as tangent. Okay, so I'm going to say my sine of theta, so the sine of my angle, the cosine of my angle, the tangent of my angle, okay, is equal to, now if I go back up to this acronym, after my SO is my O and my H, okay, so sine of theta is the opposite over my hypotenuse, okay. My cosine of theta, after my cosine, I have my A and my H. So the cosine of theta is always my adjacent side over my hypotenuse. And now I want you to go and figure out what my O and my A after tangent stands for. Okay, so my tangent of theta is opposite over adjacent. And if you can remember this, then you can remember these, and you're halfway to learning trig.